Welcome to DryAir's instructional videos. My name is Terry and I'm your course instructor. DryAir uses many different pumps based on horsepower and depending upon the size of the equipment being applied to. They range from 3/4 of a horse all the way up to 3 horse. Fortunately, their shape is very similar amongst each other. Therefore, parts are also similar across each other. One part that works for one may work for many. So let's take a look at these seals here before we get too carried away with ourselves. These seals are made of 2 hard surfaces and they're designed to go together like so along the motor shaft, and then this goes into the housing. They both have an elastomer which seals himself against the steel elements that they're protecting. This one, for example, a rubber elastomer to go around the motor shaft, and another rubber elastomer for the housing. The 2 hard surfaces, when they're together and then held together with a spring to create force upon itself, so that as the one component is spinning, it's the 2 hard surfaces being perfectly flat that try to keep all the fluids and everything else from one side to the other. Occasionally, with different temperature changes and potentially little bits of particle getting stuck in between here, you may see a little bit of leakage coming out of the motor. When that happens, we will tell you, if you call us and inquire, we will tell you that we would advise you to let it run for a while, because there's a good chance that these two will reseat and therefore the leak will stop again, and really nothing wrong with the motor. So to start with, we have the pump itself. This is a little bit of glycol that we use inside of the equipment when it's all brand new. Seeing as that this is going to be refurbished with new seals and everything else, and there is a little bit of lubricant required to install, it makes good sense to use the material that it's going to be immersed in all of its life. There's the ceramic seal. If you buy your parts from DryAir, which we strongly advise, the part number for this is 006902971. There's another seal inside, and what it does is it keeps track, it separates where the pump pressure is going and brings it up to proper speed. Quite often this will get pinched or degraded. So this particular seal is 006703008. There's an O-ring that seals this whole half off from the other half. It's a larger O-ring. Its part number would be 006703006. Nice to have some sort of a container to catch all the small parts. We have a variety of tools that we would like to use. Of course, I got a ratchet, some sandpaper for cleaning, a 7/16 flat wrench, a 3/16 Allen screw, a pry bar of some kind. If we're dealing with new parts, a utility knife, maybe scraping some gaskets, small hammer, a 9/16 socket, and an 11/16 socket. And if you have the availability of some power tools, that's always cool too. Okay, we're going to start taking this apart by undoing all 8 of these Allen screws across the front. And my favorite tool is a clutched cordless screwdriver, again with the attachment. You may have to break these free with a ratchet first just to get it loose enough that the drill will handle it. The other thing to pay note is that the base is actually held onto the machine with these Allen screws. So when you get near the bottom, I would just tip them up so that we don't lose track. There's the base and the last screw. Take this up and off. We'll take a look inside for inspection. Now, there's supposed to be a gasket in here, and I see that that's totally gone. So it's a good thing that we ordered that other seal, and we'll be replacing that. And I'll show you how to do that in a minute. We have this large O-ring. You can inspect it for nicks and that, but really it's an O-ring. Generally, we just like to replace them. On the back side here is this cap, and that's going to have to be pried off. Small pry bar, just a couple little taps, and that comes right off. The reason that needs to be off is on the back of the motor here, there is a couple of flat spots that happens to fit your 7/16 flat wrench. There's a nut on the inside that's quite often torqued in fairly tight. So for speed, I'm just going to use an impact on it to loosen it off. And there's the nut. Okay, so now we've got the impeller loosened off and it's coming up. We can take that off. We can look inside for any kind of indication of badly worn. Make sure that there's no separation in here anywhere around it. Make sure that this seal is good across here, or this surface is across here is good. The components we're going to start seeing in here is going to be a spring. It's going to be an open-ended spring. It's going to be roughed up on both edges. That has a purpose for gripping the seal so that the seal itself is attached to the motor shaft, so it's got to spin at that 3,500 RPM. The impeller is spinning at 3,500 RPM. So the spring is not only putting downward force, but it is also trying to ensure that one is matching the other. From here, to get that seal off, the best thing that we found so far is just to lightly pry up on the edges across here. That seal comes off pretty quick. To take a look at this seal, we see the ceramic on the inside here, and there's a rubber elastomer on the inside. There's also some give in here. There's some tangs that are indexed around the outside, 4 tangs. So what happens is we've got spring pressure going across this particular point here, and that's going to be holding the hard surface to the other hard surface on the mating seal. Set that aside for now. The other seal will come off easily. Again, we got a hard surface in here with a rubber elastomer between the two, and that is separating the glycol from, keeping the glycol from seeping in past that particular point. To get that out of there, One of my favorites is just the back soft end of an open end wrench. Just gently push in until it pops out. So again, we can look on the surface here, but likely we're not going to see much. You might see some scaling. Again, we got the two elastomers. You can pull that apart and look to see if there's any signs of leakage between the two. Make sure that the elastomer is in good shape and it comes off in one piece. Looking at its mating surface, we're going to make sure that it's cleaned up nicely. We're going to be looking in here for any signs of leakage in between the seal and the plate. We're going to be inspecting the backside, because this may very well be an indication as to where the leak was happening, if it was indeed leaking. From here, we're going to take a look at the motor shaft, and we're going to decide whether we're going to clean that up. In this case, we are going to clean it up a little bit. Always got to be one that's a little stubborn. There we go. Usually once these are cracked loose, it's very simple to take them out. Lift that off. Again, we're going to inspect the inside of this, and what we're going to note is that this is the top of the motor over here, is indicated by the capacitor. Inside here we've got the 4 bolting holes, and right down at the very bottom we have a weeping hole. If we remember, this plate goes on over top, and that seals the glycol from this side to this elastomer here. Then the seal across the motor shaft was separating that, so everything is staying kind of within this confine. If glycol was to get past this, it goes into this secondary part and weeps out the bottom of the motor down here. If this happens to get flooded, then what happens is, if glycol was to ever get into the backside of here, then it goes back into this weep hole and again back out through the bottom of this and out through the motor, bottom of the motor. And that's where you're typically going to see the leak, is coming out of the bottom of that weep hole. That particular leak can be caused by this mating seal here, and that's about the only seal that would cause a leak coming out of the bottom here. If it was that larger O-ring, we would see more leaking in the outside of this edge somewhere. So we said we were going to clean the shaft up a little bit. Easiest way to do that is with a little piece of sandpaper. We'll put that nut back on. Take our power tool, start spinning the motor shaft. Now, people are going to tell you there's other ways, better ways to do that, and that's fine. The important thing is the end result. Now we'll start putting it back together. Starting with this, we're going to make sure it's all cleaned up on the inside. Pay close attention to the bolting surfaces. And remember that the capacitor of the motor is up, so the weeping hole has got to be on the bottom. Okay, the next part is we got to press in a seal into here. So out of our seal package and our glycol mixture that we got using clean glycol, we'll open up our package for our seals. And I don't like to touch a brand new seal with my fingers, so just whenever you can, I just scoop them out, put them right into the glycol. Again, like we said, we were going to use that for lubricating. Not touching the hardened surface, just going to lay that in there. And press that in as evenly as possible. The important part is that when you're done, this here should be all tight along the inside. And I don't know how well you can see that, but that's tight on the inside. Slip that over top. And for the next part, this one's even a little more delicate than that one. They're made of a different material, and they strongly suggest that you don't touch it with your bare fingers. The hardened surface they're getting at, so you'll make sure that that's good and clean. Put it straight into the glycol, make sure it's all lubed up nice. Again, you'll notice I'm not touching that hardened surface. Slide that over the shaft. Now, tight is good. If you're cautious, that seal is giving you a hard time getting over that motor shaft, just take your pry bar and just work it back into place. It's seated fully down to the bottom of the shaft. And then the spring will go on over top. And the impeller will screw on over top of that. Now you'll keep screwing that down until you see the motor shaft starting to spin, at which point you're going to need to hold the bottom of that and tighten up by hand as best you can. Now we'll take the nut again and put that back on the top. That's the 11/16. Righty tighty. Take out the new O-ring. Again, we'll soak that into our lubricant. And this other gasket that we were missing, we'll lube that up a little bit, and that'll actually go over. No, not yet. I lied. You need to take this off at this point, and this should just pry out. Pry up. Just keep working it. And that's going to sit like so. And then our new gasket will sit in the middle of that. Then we put this back on. Then we start putting the screws in for it. Now, we also have to remember that the foot plate also goes on with this. And we just keep working it. There we go. It's good to go back and forth similarly to torquing on a tire, just to make sure that we have even pressure all the way around. And there we have it. New pump, ready to go. So another thing I would like to show you is how to change a capacitor in these motors. This capacitor in these motors is used for starting the motor up. So if you have a failed capacitor, there's definite signs that would tell you if it is failed. This being the most prominent. And it starts to hum like that and the motor's not turning, that's usually a sign that your starter capacitor is failed. I don't recommend experimenting with capacitors. We don't want anybody playing with them, but it is far cheaper to replace a capacitor than it is to replace the whole motor. In replacing the capacitor, the first thing we want to make sure is that there's no power going to the motor. And we start by undoing these two screws off the capacitor case. A little tug, case comes off. On the inside you'll note two wires going to opposite poles within the capacitor. Just a quick tug, get those off. Get your new capacitor. Now the thing about capacitors is that they vary depending upon horsepower of your motor, size of your pump, things like that. So if you do find yourself wanting a new capacitor, please feel free to call our parts department and give them all the information of horsepower size, equipment size, stuff like that. Again, you'll place them on one terminal onto each post. Line your gasket up. Place the capacitor case back on. Some of you mechanics out there are probably cringing, saying, oh, he's closing the hood before he gets it together, but when we're playing with power, it's kind of a good thing to get everything closed off as best you can. And I realize I have an open cap here, but I'm also in a controlled environment. New cap in, we'll plug it in, and proceed to test. Now we have a good working pump motor again for about $50 in parts.